Hello, everyone. Can you hear me? Okay. Okay. As already has mentioned, thank you for joining me in this talk after lunch. We're going to talk a little bit about CQRS, which is a very light topic. We know about that. And I would love to start with this quote of Frederick Brooks, that it says, "The success of the scaling up process depends upon the fact that the conceptual integrity of each piece has been radically improved." So in this book, Frederick talks a little bit about how increasing the manpower to speed up a delayed project often has the opposite effect to the added complexity of communication and coordination. We will see a little bit about this concept, about conceptual integrity, and how that can help us with CQRS to elevate our system. My name is Javiera Laso. I'm a software engineer at ThoughtWorks US, and I hope you enjoy this talk. Let's talk a little bit about observing systems in nature. But what nature? Our nature, as developers, as managers, as architects, as engineers. How many of you are managers? Okay, how many of you are very technical people? Okay, that's a very interesting mix. Okay, so when we are creating, when we are designing a system, we need to choose an architecture. Usually we start with monoliths. That's a very good idea because we can modularize them and then we can evolve them. But also sometimes we say, you know what, I want to start with microservices. Or you know what, I read something so cool on ChatGPT that it says that we need to do event-oriented services. The whole company is going to start using Kafka from now on. How many of you have used Kafka? Okay, that's a lot. So, and the use cases for that are very interesting because sometimes we say, why we're using Kafka? Is really what we need in here? And the question is correct. We need to try to understand what are the system's needs. So when we think about what it needs, we try to think about the cohesion, the consistency of all the underlying processes. And in here is when we like to think about conceptual integrity. How are the relationships? How is the domain understanding of our system? What are the needs? What is the flow of information? How are we gonna choreograph our system? If you ever been in a concert or if you are ever been a musician, you know like any music piece, it's independent, but as a whole, we have this choreography. We have this consistency, and it's the same as our systems. So we need to make sure that the conceptual integrity remains so we can choreograph our process in the correct way. If we just see the violins play by itself, we'll see the melody. But if we see only the percussion play, we'll see, okay, well, it's nice, but as a whole, it creates this melody and this integrity of our systems. And when we describe our systems, for example, a health management system, we often know a lot about our company and what we are doing. We say, okay, this health system has the patient information well described. It also has the exam systems, because of course, if I'm going to the doctor, I need some exams so they can see what's happening with me or what do I need. We have payments. Funny or not funny, a couple of days ago, I was on the ER with my dad, and there was a lady with a small computer, and that was the payments lady. So she has their own system, and she was making sure that anything that they get there is going to be billed afterwards. This is the US. And also the scheduling system, because if we need to do some tests, we need to make sure that the schedule system is up to date. We know also the operating room system, the hotel system that is after you are admitted. I don't know if you know, but it's called hotel. It's not the same quality as this one, but it's a hotel service. So when we're describing our systems, we say this. And we picture as we are talking this beautiful and organized system. But what happens if we look deep down? What is the reality of our system sometimes? Usually when we are working in these huge organizations, we see that, well, the context, the bounded context here aren't that clear. We know what the system do. We know what are the events. We know what are the domains, the subdomains. But in reality, when we go and try to extract that information, when we try to scale, it's not that simple. So in here, we see some disorder. We see some discrepancy. But also, we start seeing that the entropy is actually increasing. To make this topic a little bit more light, we talk a little bit about entropy. So when we think about entropy, we describe this in physics as a measure of how disordered something is. And this is the basic symbols for entropy. So in a closed system, entropy is going to be increasing over time if the pressure is too high and it doesn't have any release method. And high entropy can lead to difficulties maintaining and updating our systems. Everything changes. COVID showed us that everything changes. The necessities of today can be different from tomorrow. The government rules change, and this can lead to difficulties when we are trying to evolve our systems. So this entropy is going to be very interesting, because if we don't have a release method, we're going to get stuck right there. And as we evolve, the systems evolve. But, okay. We talk about entropy, we talk about conceptual integrity. Let's go to our main topic, which is Common Query Responsibility Segregation, or CQRS for my friends here. The main idea of this is separate, as you can read there, the read and write operations. So the queries retrieve data without altering any state, and this separations allows each size to be optimized independently. We try to improve performance, we try to, with this, improve scalability, maintainability, and also have an independent optimization. If we are able to introduce this concept, we are going to be able to maintain a system or part of a system in consistency. This conceptual integrity is going to be maintained in the whole. But this does not mean that we are going to apply CQRS to each of our services. We need to understand we need it or we don't need it. To go a little bit more into the details of CQRS, we need to understand these three main concepts. There are events, comments, and queries. Very popular. We have heard about events. Of course, we heard about domain events, event storming. So we have a notion about what events are. So it's the notifications that something happened in the system. In this case, could be the patient record was updated. Okay, that's nice. Or the prescription was ordered, because we need to make sure that this is something that the person afterwards, this visit to the ER, to the doctor, is gonna get. The comments are gonna tell us a little bit about the changes of the state of the application, like what you need to do. You need to discharge this patient. This patient needs to leave. Or you need to schedule an appointment. Okay, this person now needs to go and see a cardiologist or someone else. And the queries are the operations that are going to retrieve the data without modifying in this concept of CQRS. What happens if we try to get the patient record? What happens if it is or it isn't available? or get the prescription history. This is very important to have, because what happens if I'm allergic to penicillin? What happens if I don't have that information in hand? So in this case, we need to make sure that this information is available and is not being modified on any time soon. And also the list of recent admissions. So maybe this person already came to the ER a couple of times before for this, and that. So that's going to help us to get a much better diagnosis afterwards. Okay, for the people here that loves diagrams, and there were a lot of words already. So what is the principle while working with CQRS in terms of this flow diagram? We have a user that makes changes in the UI. We have these first steps. Then we move into the command model. We're going to have our app that routes this information in this command model. And inside the command model, we are going to make sure that any validations, any operations happen at this time. So after that, we can update this database. This database is going to communicate with the other one. We'll see a little bit in a minute about how that happens too. And what is going to happen is this query model is going to read from the database, and after an event happens from the UI, it's going to retrieve the data. So if you take a look on the arrows, they're not like all the way like this. It's more like something happened, and we need another event to go and get the information that we need. Now, how is the data synchronization between the read and write? There are different ways to do this. I wanted to show you the event bus that acts as a messenger that ensures that everyone in the system gets notified when a specific event happen. This is going to help us to stay in sync without needing direct connection between the components. In some cases, you might need just some catching, some retry logic, or idempotency checks to handle some networks problems or delay, so we can ensure this readability across systems. Okay? This is a pattern that we can use, we can code, and we can make sure that it's gonna be useful for the needs that we have. But this is the hard part. When CQRS is not going to be a good fit for us, because it's very easy to say, okay, ChatGPT told me that I need to use CQRS in my whole system, in my company. Now we're going to do that. But what happens if we have a simple CRUD application? Why will we waste some resources on this? With an application like this, we don't need CQRS really. What happens if our legacy system has some constraints? What happens if our big ball of mud is so muddy that we cannot operate inside? Maybe we need to first identify what patterns or what services can be extracted. This happens also not only in monoliths, but also in services or microservices that are no longer micro, not as like anywhere that was micro before, but it's growing so much that now we need to refactor, we need to do a stranglerific pattern, a lot of things before we can start applying this. Also, we can have resource constraints. This means money, this means people, this means knowledge that we don't have. How are we going to move into a pattern that it needs a lot of effort from the company to happen? And also, we have a low read-write discrepancy. We don't have any disparity on this. We don't need to have the information stored in one side and read in the other. So why are we going to change that? If it works, it works. But if our use case needed, we can think about it. And also, if your domain has minimal complexity, sometimes we don't have enough use cases to use this. Maybe our use case is so simple right now that we don't need CQRS in the moment. We need to identify, okay, how is the domain complexity? Is it complex enough to do this? as you've seen sometimes before too, when we talk in terms of domain-driven design, we also are looking for some number of use cases that this can be escalated. You can read this in the Red Book too. But how we can identify that CQRS will help us? There are some cues that can give you a clue. So if we have complex business rules for state changes, it's a very strong case that you can tell your boss, we need to invest in this. So we will try to enforce complex rules without impacting the performance, and this would allow us to access to the key information very fast. When we're talking of a bank, this can be translated into credit checks or fraud detection, income verification, and even government and compliance. We need to make sure that we have the information right there. We have the history. We know what is happening. And sometimes the CQRS model is the best fit for these cases. If we have a high read-to-write radio, for example, if we have a flash sale, this is translated in the US, for example, of a Black Friday. I don't know if you have something similar here with other names. It could be. So the main idea of CQRS is to optimize this read side for a rapid data retrieval with caching and some load balancing, and it's going to ensure that the users can browse products seamlessly, while the right side will focus on maintaining the data consistency and handling the complex order processing. This is going to help us to allow the inventory updates to happen asynchronously without impacting the shopping experience. I don't know if you've been in these websites, they have a flash sale, and it's very hard to navigate because, okay, the lazy loading is too lazy, or if I'm trying to order an item, it's very hard for me to make sure that, okay, it's one order or more than one order. Flash sales are a very big event for companies, for e-commerce, so we need to make sure that we assure the quality of the experience along with the integrity of the system. Another use case in here is different read and write models. We need to optimize for usability. As we can have, for example, detailed medical records, while the read side quickly retrieve or summaries of these critical alerts. Oh, this person is actually allergic to penicillin. So we will have this quickly access to important information during emergencies while keeping a complete history of the patient intact. When we have this diagnosis, we can have the medical changes. All of these use cases are good use cases when we are thinking about CQRS. So I hope now you're having the back of your minds, oh, maybe I have one or two cases of this. Maybe not in the health system, but around that. Also, in another example is distributed systems or microservice architecture. A very interesting use case here when I was talking with my colleagues was in the online gaming system. In here, we need to, for example, allow the player's profile service to trigger events that will update the leaderboard. If you are gaming online and you have a table there, you want to see your name as soon as you reach out the target, right? So we need to have this leaderboard service or this game session management that can use the CQRS or the in-game transactions that are very important. This needs to be instant. It's very similar to a bank. It's just in a different context. And also the game events login. So again, we can have a history of what has happened, how we can retrieve the information, and traceability of all of that. Having said that, we can go back and check again. Okay, am I thinking correctly? This resonates with my use case? We remember, okay, no simple CRUD applications, legacy system constraints, resource constraint, low read-write and null discrepancy, and minimal domain complexity. Okay, this is not a good fit. We already know that, and we have a few examples on how we can use it actually in reality with a use case that I can tell my manager, my CTO, or anyone, okay, this service needs this. It's not the whole company. Not everyone needs to learn Kafka this time. But, okay, and we are trying to understand from our perspective how we can integrate CQRS. What tools can help us to do that? And in here is where we have the connection of integrating domain-driven design to optimize the architecture of CQRS or the usage. If you've seen this image before, we have this domain-driven design starter modeling process. It's very important for us to understand that this modeling process is iterative and is continuous, and it will change over time depending on where are we in our journey. We will align some stuff, we will discover, we'll strategize, we will have conversations. There is a lot happening when we talk about domain-driven design, and sometimes it's very hard for us to identify, okay, which part on domain-driven design I need. Do I need to do an event storming? Do I need to, or not? Sometimes you do. What happens if I don't understand the domain events? We actually need event storming right there. You have a cure right there. Let's take advantage of that. So when we take advantage of it, we can say, okay, using domain-driven design can give me some clear domain models. Also, can help me to realize what are the bounded contexts. We will create these boundaries around the context. Aggregates. I know that you already went to talk about aggregates, so you know a lot about this already. We need to identify domain events. The ubiquitous language is very important. Even on CQRS, if we have a common language per bounded context even, it's going to be much more easy for us to take decisions. If we're talking to update the patient record, it's the same language that our business is using, or when we're processing a payment, when we are scheduling an appointment, it's very important for us to understand the language of the business. Even when we can reuse this across other contexts, it's important for us to individualize for our domain. And also, it's good because we will have some idea to do event sourcing compatibility. And here it's very important to understand that event sourcing is not a requirement to do CQRS, but it's very common. Okay? Now we're coming to see a little bit about implementation. Don't worry about this. I'll share some code snippets after this talk so you can take a look about the implementation of an aggregate root pattern. The main idea of this pattern is to define on a context that an e-commerce, when an order is placed, we will have the comments that we will place an order and add the item to an order, and the query, after there is an event trigger from the front end, will retrieve the whole order details. In this code, I'm trying to show you how this can be modeled, what are the components on it, and how we can trigger also an exception if it is needed, okay? In here, it's very important to understand that when we are using these methods, it's also trying to ensure that the order, in this case, is placed only once. If we click 10 times, the order shouldn't be placed 10 times. If we click once, it shouldn't be multiplied. So it's very important when we do this implementation also to test that we are, in fact, coding this correctly so the business won't suffer. The business hates to lose money. We hate to lose money as users. If we place an order and it translates in 5 charges in our credit cards, we aren't going to be happy either. The other pattern that is interesting to take a look into the coding implementation, it's the event sourcing. When we know that events are going to be stored in this event store, and the current state is going to be reconstruct and replay events. This is going to benefit a lot and provide us like an audit trail and the ability to reconstruct these past states. If we're talking about some patient's record, medicine's record, any case, you can definitely use event sourcing along with the whole implementation. And here I'm just showing you the patient aggregate that is going to generate these events, but you need to make sure that you have an event class, you have the aggregate root, you have a command class, a command handler, and a repository interface. All of those are going to generate this CQRS model to work correctly. If we think about, again, what are the limitations of using CQRS, and we think about the technical limitations, we need to make sure that when we put this in hands of the developers and we tell them, okay, me as an architect, I'm going to tell you, development team, you need to start doing CQRS. We need to go and code with them at least once, because this is a change of mentality too. When you are implementing CQRS, it's not as simple as, okay, just write in the database and just read from the database. It's a pattern, and we need to follow the rules in order to abstract from that, in order to test better and take advantages of what we are doing. Otherwise, it's not necessary. Again, if your use case is not enough complex, skip this. But what are the challenges while we are doing this? There are a few. Well, I was talking with a couple of teams about their experience implementing CQRS. There were a lot. But the ones who repeat and the ones that I experienced myself with were the increased complexity. When we are implementing CQRS and we are not very sure about how this works, we need to make sure that we transfer knowledge to all developers. We have documented this process, because also our infrastructure can overhead. We need to understand that implications are going to be not only in development, but also in the costs. Then the testing. The testing was very interesting, because in one of our clients, they weren't very happy about testing in general. But if you are not testing, it's very hard to understand what is happening. At least an end-to-end test starts small. You don't need to test each single point at once. You can start integrating. Also, handling business logics. We have aggregates, but do the people know how aggregates works? They know how to implement these aggregates and translate it into business rules? That's a very interesting challenge when you are developing this CQRS pattern. It's very important to make sure that everybody is aware on how we can translate, have the conversations, and share this with all the involved parts. Bring your domain experts. When you are modeling in your event storming and you are in the amazing part of defining the aggregates, make sure you pause and read what is happening right there. So sometimes when the managers are there, they're not going to understand, but you can go and say, this is the aggregate that translates into the business rule that you are talking to me. Are we agreeing on it or not? So it's important to have everybody involved. If we are just going to start doing CQRS because our teams think it's the best scenario, and we are going to take advantage of the situation and not going to translate into a conversation with the business, at the end of the day, the only affected people is going to be us. And again, the ubiquitous language, the inconsistent terminology. When we are developing CQRS, this is a very big challenge, because between contexts, we sometimes will like to share some database data, and we need to make sure that this is possible, but also it's in our context. If we are going to overlap or if we're going to duplicate some stuff, we need to make sure that we identify this as a progress in how we are going to implement. The terminology is very, very, very important. We need to make sure that our entropy does not increase after we implement CQRS. We need to make sure that after we implement this, it's going to be a release, right? So let's think a little bit about some key insights for the success that we have seen in the consultancy space for some time. Start small. When we start small, even when this is kind of a cliche and we say, yeah, let's start from a service, it's okay. Companies don't want that all the time. They want to address this big use case. And you can do it with resources, with knowledge, you can do that. Starting small doesn't mean that you need to use the smallest services. It's that you're gonna take a conscious decision and you are going to evolve your application in a conscious way where you are gonna maintain the continuous integrity of the whole system. If this needs to be refactored, you will start small because you will abstract your bounded context and you're gonna take a piece of there and you're gonna start developing what it needs to be developed. Use event sourcing carefully. This is very important because we tend to say CQRS is bound to event sourcing. And this is not very true. It is a good pattern that is going to help us a lot with CQRS. But also, we need to make sure the cognitive load is enough for the team to take advantage of. If they don't understand very well what is event sourcing, send them to here. Bring them to conferences. Start talking. Be the agents of change. If you're seeing that this pattern specifically is going to help you to implement CQRS in your system, that's a good start. Invest in automation. This also may seem as obvious, but investing in testing is very, very important. I've seen this a lot in the US. They don't like much the testing. The same in Latin America. I'm from Chile. It's because they see this as a waste of time. We need to change the mentality. I'm not saying that now you can put a ChatGPT method that is going to test at all, but at least understand the test. Let's talk with the business. Let's say, okay, what is the test that makes sense? Involve them. Sometimes we're trying to unit test some stuff that might require some time, and it's because we think it might involve the business. Let's involve them for real and talk about it and automate this test. Because also sometimes what happens is that we hire these manual testers who are going to just check, okay, this data was present in the database, and when I retrieve this other data, yeah, it was there. Is that a real testing? Is catching there somewhere? Are they testing like for real, or they're just clicking and retrieving and postman for the win? Make sure that that's happening correctly. And monitor and optimize. We need to regularly review the system for performance, for the bottlenecks. We need to make sure that we are monitoring. I've seen a lot of times in big companies that they don't invest in monitoring. For example, one of the companies that I worked for, they didn't even know which one was their queries for Splunk. So if you wanted to trace something, some errors, they didn't know, but they were enforcing Kafka like it was not tomorrow. It was the most important thing, like everybody knew Kafka. But when you ask about monitoring, it was crickets. Oh, what do you mean? It's logging somewhere. Okay, we need to make sure that we are monitoring and we optimize this monitoring because our system is going to evolve. It's going to get more complex. And in here, it's very interesting. Sometimes when we try to implement CQRS in an organization, we decide that, okay, this is the model. Something very interesting that happens too is that I don't want to use the term CQRS. And this happens in a lot of companies. You might realize after this presentation that you are actually using it right now, CQRS, but you don't use the name. And that happens a lot. This is a pattern that can be in nature too, that can be discovered, or sometimes we usually don't say that we are using it. At some point, talking with some colleagues, they say when we approached to the client and told them we need to implement CQRS, they were very afraid of it, very, very afraid of the term, what implies, and all of that. But they start small. Currently, they are using CQRS, but they don't know that that's the pattern, that that's the name of the pattern they are using. So you can have it, you can start introducing them and having the conversations, but not naming necessarily that you are doing that. At the end of the day, we don't want the entropy increase. The technical debt is going to always increase, and this is going to lead to more complexity. The higher costs on maintenance are very hard to decrease along the way. So if we relieve our systems, if we relieve this pressure inside of closed systems, it's going to be easier for us to make sure that the data is consistent and also that what we are implementing responds to the use case that we are actually want to resolve. Thank you very much.